Hello. Thank you for joining me. I'm Chris. I am a senior software developer with technology partners in Bayer, and as you've probably figured out, I'm here to talk a bit about functional programming. I also write genre blending sci-fi fantasy novels for a little bit of personal information about me, and that's what's linked to with my website on the current PowerPoint slide. If you're interested, I'm giving away a book for free. But with that, here to do what I'm supposed to be talking about, which in this case is functional programming. And functional programming is not necessarily just a different way of writing programs. It's also a different way of thinking about them. And sometimes it can sound like in order to start, you have to jump right into functors, monads, category theory, functional composition, all of the math stuff that sometimes makes people's heads spin. Some CS postdoc is here to drop a knowledge bomb on you, and then it is your job to RTDM and figure it out for yourself. In short, here's the knowledge, and now it's time for you to get good, noob. Unfortunately, not everyone actually learns that way, and for a lot of times, it's much easier for people to build on to the knowledge that they already have. Start with where you are, and then build from there. It's one of the reasons I like JavaScript as a way to branch into functional programming, because you can do a mix of imperative and declarative styles. And it's not something that locks you into those paradigms where you either have to get it right or nothing's going to work. It's a bit more lenient, and you can bootstrap your way to success. And as I was mentioning, functional programming is a different way of thinking about programs. It's in contrast to some of the traditional class-based, object-oriented programming paradigm you may have learned if you start out with a CS degree or programming languages like C#, Java, those which kind of have to lock you into that paradigm in order to make the programs work. And one of the fundamental differences is between how you break up and analyze the requirements of your program. In more traditional class-based object-oriented programming, you have a bunch of objects which talk to each other. They have internal variables, internal state. They send messages back and forth between each other, and then through the power of togetherness and friendship, they work most of the time. In contrast, functional programming can be thought of as more of an assembly line. You start off with some input data, you process it through some functions, you process it through more functions, process, and then at the end you have the output data, which you're usually going to do something with side effectful. And so that distinction between groups of interacting agents versus one pipeline you kind of cram data into and cram data out of is one of the conceptual distinctions that, if you use that as your guiding metaphor, can make it a bit easier to switch over, so that you're not constantly trying to figure out how you do something object-oriented in a functional programming paradigm, because it's just not going to work, because that's not how you're supposed to think of programs. Another way to think about it is object-oriented programming breaks down projects and programs into nouns. How am I going to break this up into things which do stuff? Where am I going to store things? How many mechanized filing cabinets of data I'm going to zoom around and have them talk to each other, whereas functional programming breaks down programs into verbs. What processes do I do? What am I trying to accomplish here? Which data do I need to come in and then come out? It's a shift that can make your head hurt the first few times you're trying to talk about it. And so in this presentation, I will be mentioning this, and then also giving some strategies using Lodash, the Lodash library, and the JavaScript to make it a bit easier to make the jump from fully object-oriented to something a bit more functional. As I mentioned in the presentation description for the meetup, which Darren was kind enough to post. I'm not really going to dip into full functional programming, so if that's something you're looking for here or watching the replay of this, feel free to find something else to do with your time now. I'm not really even going to get close to monads. But if you're looking for a way to see what all the fuss is about and perhaps bootstrap your way up into a new and potentially more efficient way of doing things, well, feel free. These slides will also present the information in a few different ways, whether it is some math symbols, some metaphors, some pictures, because different people learn different ways. And if you have any questions in the room, feel free to speak up, be a bit more interactive, and if nothing else, will help keep some people's eyes from glazing over. I appreciate their fortitude, but I'd rather they not waste their time either, even if it's just to get a laugh out of their day. And the title of this presentation is Set Operations in Lodash. One of the ways to start thinking in terms of objects, of functional programming rather than objects, is to start giving a bit more of a focus on the data structures you are feeding into it, rather than simply saying, I'm just going to write a wrapper class, put some accessors on it, it'll be fine, I'll just tell them to read the docs about how this works later. The focus on the data coming in and out is one of the hallmarks, and today we're going to start dealing with sets. Some of the purists out there are eventually going to point out these are technically multi-sets, but I also don't want to go that deep into it right now either, so I hope you will forgive me and just bear along for while this lasts. And for those familiar with JavaScript, the multi-set or set is really a concept of arrays and objects in disguise, where an array would be an ordered set or multi-set, which is basically a bag of stuff where there's an order to the stuff inside of it, and that order is reflected by the array index, whereas an object is an unordered multi-set, where there's a bag of stuff that has no implicit ordering to the stuff inside of it, and that's why objects are accessed via keys instead of array indexes. Since JavaScript is JavaScript, you also have array style access for objects in keys, but it doesn't really change the underlying implementation of the data structure. And then together, the array and the object, you do a union over the two, and you get the concept of a multi-set in JavaScript, basically a place you can store stuff. And with regards to some of the math symbols, that apparently small caps U is the union set operator, which you'll be seeing a bit more of these types of operators in the slides to come, if that's how you learn concepts and something you can hook onto, if that's what you prefer to do. And so now we have the arrays, we've got the objects with the array type access, got the overarching concept of a multi-set, which in Lodash is called a collection if you are looking in their docs. Lots of different names, lots of different ways to access things, and as far as why this works in this particular framework, this particular language, the answer for now boils down to because JavaScript. This is how the language works. If you're going to program in JavaScript, you're probably going to need to live with it. Unless you want to do TypeScript, that's a different story. So, moving on, we are working with arrays and objects. To simplify things, we're going to start working with arrays. The Lodash documentation is well enough written that when you want to start working with objects as well, it'll help guide you through it. But for now, on the concepts, it's a good place to start. And here we go. Map, filter, and reduce. One of the things that tends to throw people when they're making the jump away from imperative object-oriented style programming towards functional declarative style programming is, how do I deal with arrays if I'm not supposed to write for loops anymore? This makes no sense. I am done. And Map, filter, and reduce are the idiomatic ways of working with arrays. There is a native ES6 implementation for these three, but since this is theme of this presentation is doing this in Lodash, we'll be using the Lodash ways. There are a lot of ways the Lodash version is syntactic sugar, but combined with some of the other deeper features of the Lodash library, it makes things a bit easier, but again, that's out of scope of this presentation. So we will start with the concepts for now. There are some various definitions of how these functions work on the slide. At the top is a somewhat corrupted version of a Hindley-Milner notation to describe the functions. And I'm still not entirely sure if I am pronouncing this correctly, because I either say Hindley-Milner or Hindler-Milne, and whichever one I seem to settle on, I get it wrong. And it's a way of typing function using in functional programming. It's a way of describing the function signatures so that you can get a sense of what they do without actually having to go through and read every single line of code. And given JavaScript's lack of a native type system, I usually end up putting these as comments on top of functions as reminders to myself later. But because JavaScript is not typed, I've ended up going off on my own, doing notes to help me understand and how I realize things. So hopefully this is enough that will help you get a way to wrap your head around it as well. So map takes an array of anything in it, and it returns an array with the same types of anything in it. The array brackets around the star returns the array brackets around the star. One of the salient features is that the size of the input array is going to equal the size of the output array. However many things you got going in, or how much stuff you've got going out. And it is really useful for transformations on the data included inside the array. And the last bullet point there is due to the way that Lodash implements this, you pass the array in first, and then you place the map function second inside the function call. Whereas the function you pass is the function that is going to be applied to each element of the input array in order to get the data in the output array. And there is one of the first answers to, well, how do you deal with arrays, say, results from a database if you can't use for? Well, you put the results into an array, and then you map over it if you're going to do any changes to it. That's the transformation part of it. The next function on the list is a filter, which takes an array of type A in it, and then it returns an array with the same types of stuff in it. The salient feature here is that the size of the input array is always going to be greater than or equal to the size of the output array. As a filter functions like a filter. Some of the elements in the array are going to make it through, others will not. If you're more familiar with the back end and working with databases, it's somewhat equivalent to putting a where query on a map, like a where query on your array. The array is conceptually similar to the data you got in the database, and you're trying to query it according to certain criteria. And then the last line is something a bit closer to Lodash's actual implementation in the code of how the function works. The last function is a reduce, which is taking an array of values and returning one value out of it. It's one of the biggest examples of some functions you might have already seen in JavaScript, which are effectively reduces in a different form, would be like array concatenation into a string. You've got an array of multiple values, and you're trying to turn them into one value, which is a string. Because the value you come out with may not necessarily be starting with the value that you have in an array, It tends to be a little more flexible than that, but that's a good place to start. Reduce is good for aggregations and transformation sets. And there in the last line was the Lodash implementation where you have the array, you have the reducer function, and you have an aggregator of type A, and then the function is going to return a single value of type A. Yes, Kevin?
What do you mean by transformation set?
Oh,
Can you repeat any questions that are asked for online?
Oh yes. Kevin in the room was asked about a transformation set, and that would be, going back to some of the mathy things, would be a set of transformations or a list of transformations that you want to apply to a set of data. Like, I want to increase the counter of hits for everything by 1, and then I want to change their name into sentence case for display. This is like if you get something from a database back and you need to pretty it up for display on the screen, and you need to apply more than one transformation of the raw data. Each of the individual processes would be an individual transformation, and then the array of transformations would be a transformation set or a set of transformations. I have an example in the live demos I'll be showing later in the presentation. Would that suffice for now while we get there? All right, he is nodding, so I will move on instead of hearing the follow-up question and pretending it didn't happen, because we are on a schedule. So with that, here's another visual way of interpreting these functions in case you're more of a visual learner and prefer some of UML type diagrams. Where map on the left, we have a set with values A, B, C, and D. We have the map function. And then on the right, our output is the function applied to A, the function applied to B, the function applied to C, and the function applied to D. In the middle is filter, where we have the same input array, a filter function, and then based on the results of that function, we end up with some of the elements but not others. And then on the far right, we've got the input array, some start value, a function that does, well, I can't call it magic because that's a technical term meaning nobody knows what's going on, but a processing function and then a result at the end. Now, use cases. Map tends to be good for table lookups, bulk outputting, and bulk formatting data. Filter tends to be good at extracting selected information from it. Particularly, say, if you have an array on the front end, an array of stuff to display in a table, the user is going to select some of those items and then, say, export to CSV. You can use a filter to extract the selections, or, as the name suggests, apply filters. Reduce can be good to join data, as in the array concatenation into a string, run transformation sets, which we will get to, or as a way to create pipes of functions, similar to round a pipe or some of the piping syntax you might see in other functional languages. Like, I believe Scala has some shorthand to run one function after another in a certain set of information, which I saw by screen looking at some of you guys here, so thank you. Get more data information on how other languages work. For those a bit familiar with JavaScript and wanting to know how these work with promises, here's some additional data to throw at you, the async await versions of how to make these work if some of these require promisifying network calls. If there are any questions, I'd be happy to go through and break this down. But if not, I'll move on. There's a bit of a balancing act here to go to try to reach out to people who are starting out and curious versus those who've done this for a while. And you can't always hit everything, but I would like to try. So at the moment, are there any questions on this slide before I move on? Oh, apparently not. Here's an async await version of reduce for those interested, and for internet posterity, since once this gets posted, it will never be removed. And boom. All right, next set of really useful functions to use when dealing with arrays in Lodash. And then, Kevin, we will get to the live demos, don't worry.
Can't wait.
Is union, intersection, and difference. Inside the parentheses, you'll see the mathematical symbols for them, in case you're more familiar with that. And union does, with that fancy syntax, is it takes an array of arrays of any type. That's why you have that star hiding inside the brackets like some kind of spider that's about to eat your code. And then it returns a single array of any of the type that was inside the other arrays. It is conceptually equivalent to an outer join on database tables. And the way that the Lodash library implements that, it removes duplicate items that may be in both arrays, more closer to the pure mathematical definition of a union over sets. The intersection has the same type of functionality, takes an array of arrays, returns a single array. It conceptually acts like an inner join on database tables. And it also removes duplicates, so closer to the mathematical definition of a set. What difference does, same thing, takes an array of arrays, returns a single array, and finds elements that are unique to the first set or the first array that's being passed in. And in the Lodash implementation, it actually keeps duplicates if the first array you've got has duplicates. It's a bit of a difference between the way the other two functions work, and so it can throw some people if you're not used to it. For those more comfortable with graphs and visual style, here's a taken from the open source description of SQL joins, the visual way to interpret union, intersection, and difference. And use cases. Union, can be used to combine lists of usernames. Say if you have to query two different databases to figure out what's going on because someone's migrating over from legacy code. And instead of writing a really big custom adapter, just take the data sets, transform them so they have the same structure, then union over the arrays you got. Intersection can be used to validate arrays against other arrays. Like say you have a list of commands and you want to, or HTTP addresses you're allowed to make CORS requests to, and then you want to whitelist them against an array of addresses that are valid. That way you can use intersection to streamline the checking process rather than doing some kind of like potentially a for loop structure and checking each individually against something else. And difference, to show you the difference of something, can be used to find missing configs or to check to make sure you have all the data you need for a certain things to happen in your program. And in JavaScript, again, because of the lack of typing and compile time checks, that can be a bit useful to put in there so you don't break as much as you thought. But all of that is particularly abstract. We're still at a conceptual higher level of how these works. And so at this point, we can move to the live demos. If you are interested in looking this up on your own computer and tinkering around with the code while I'm working around up here, these are two links that should get you to roughly the same place. First one, you'll have to look for the one that's linked to this presentation title for the set operations in JavaScript. The second one should take you directly there, but not everyone natively speaks hash code, so it's nice to have both. So with that, if there are no more questions in the room or anything, I haven't been talking over anybody, have I, while you're trying to ask something? All right, let's switch over. There we go. Nice. So this is set up so that it outputs a lot of things to the console, so that I didn't set up anything too fancy for the presentation. and hopefully make it easier for those who are interested to mess with the code and see what works, see what doesn't. And for this demo, we got some data which we are pretending is coming back from a database of some sort. There's been some XML call in the background, and we got pretty standard database structure. They're keyed by ID. They have some names. They have places they live, and zip codes and phone numbers, which will not get Oklahoma sued for harassment if anyone tries to call them. 555 for the win. And then we have some helper functions here. Get person from table, which uses some more Lodash, which takes the data source, and we get some IDs. We've got a logging function, which wraps the console.log in a function to keep with the functional style. It can seem like a bit of unnecessary boilerplate, but as far as refactoring goes, we can take out console.log with your log of your choice, and then you switch over to whichever logging system you prefer, and then the rest of the code does not need to be refactored. It's a way to make it a bit more modular and pipe it through the chain. And then we get to some of the transformation functions we're talking about and asked about earlier, like how to strip zip code extensions. And this works on a single object, generic object. We're going to get a zip code from it. If it's not a string, which we're assuming we're going to be working with in this demo, we're just going to return the object, kind of like the no-op for kind of a JavaScript-y way to put some type checking safety in there. If not, we're going to get the new zip code, and then to avoid object mutation, which tends to be another no-no in functional programming, we're going to return a new object, and this is a Lodashy way of doing it. Then we've also got an add combined address function, which takes an object. We get the street, city, state, and zip code. Do some JavaScript-y type checking. Then we're going to combine them all. Create a new object with a new property called combined address on it, and return that. And that is all these functions do. One function does one thing. We're thinking about the processes we want to do to the data rather than who wants to do it. And then we are going to work with that. And then we get to the actual meat of the example. We got some people IDs we want to work with. Some of the JavaScript purists will point out that declaring this people IDs array with const really doesn't do anything because it's an array or object type. It doesn't stop you from changing the data inside of it. And that's valid. I really don't want to go on into how JavaScript's references system works, where some things are assumed to be by reference, assumed to be by value, and how the pointers appear to act, since JavaScript doesn't expose pointers. So for now, const is kind of a linting hint to myself that this data should not change. If it does, the first place to look for bugs. And again, with one of the functional programming ideas is you want to mutate as little as possible in a function so people can skim and figure out what's going on as fast as possible. Code is read much more often than it's written. Then we have the working data, and here we see our first map. We're going to take the people IDs, and for each, we're going to take an array of people IDs, and for each ID in the array, we are going to get that person from the table. So like the table lookup part of using map. We're going to transform this array of IDs into the array of people that correspond to those IDs. No for loops. Yes?
Didn't you set up a logging command specifically so you didn't use console log?
Yes, I did. Nice catch. But, and we're using it here in the mapping here. And so this here for some of the, to make it easier to show, and at this point the ROI for this presentation did not necessarily land in the favor of taking all these console.logs out for the labels in the display. But if you are right, if we're doing this as a purely functional style, we'd want to inject something into the processing chain, but that can take a bit more doing to do it in a way that's both solid and easy to swap out and maintain. And so as far as the logging of the actual data we're working with, to prove that the map actually gets the data we're looking for, we are taking the working data and mapping it over to the log file for the side effects. So that's where that part's happening. Then we're going to do zip code extensions where strip zip data. We're going to map working data and funnel everything through the strip zip code extensions function we showed you earlier. Then we're going to add the combined address data here, and then a console.log for done to show that we've got everything working. And one moment while I look behind me so I can see how large these windows appear to the people watching. Okay, it's not too much bigger than it looks like on my laptops. And here, come on, you can do it. Okay, there's this one. I have to lift both? Wow. That's good to know. Okay, there's some kind of constraints here. So I'm going to start off with logging. Here's the raw data from the database for persons 1, 2, and 3. With the zip code extensions, we pass them through the map of the strip zip code extensions. They are gone. Then we pass them through the map of the add combined address. There's a combined address property on here that combines it in the way we expected. And then we are done. The demo is over. And it does look like, if you're not used to it, that there's a little bit more boilerplate involved in setting up all these functions rather than just writing a class that does all this for you. You're going to load it in there, call the functions to do the stuff, and then the class outputs it for you. But when you get down to the meat of the program, where it's actually doing things, it is one line each. And it is also, and just from reading this, well, first we're going to get the person from the table, then we're going to strip the zip code extensions, then we're going to add a combined address. And so it's a bit easier for someone skimming the code to realize what's going on and if there is a bug in a certain area of the code base where you need to start looking. The payoff comes in the readability and bug hunting, troubleshooting. And that's one of the things that sometimes get lost a bit in the online arguments of why an imperative coding style can add improvements to your code base. This is why. No, not imperative, I'm sorry, declarative coding style over the imperative. Instead of each line being what is supposed to do, you're describing the program to the next human reader to come along and then trusting that each of these individual functions has been unit tested and knows what it's supposed to do. And this is a bit of a base use case for mapping over arrays. And I didn't have to define any classes. I didn't have to define objects. I didn't have to worry about them talking back to each other, or some of the old C# style, Java style, where sometimes you see the code bases where you have the property, you have the accessors, you have the setters, you have the type checking, and sometimes you get like 5 or 6 different layers, including some interfaces, operator overloadings for different types. And building it in here can get you away from some of that. Any questions? None in the room, and I can't hear anything online, so I will assume it's safe to move on to the next demo, which builds on the functionality here. Set operations in Lodash number 2. We still have a set of data, same data, so I'm not going to try to throw you for a loop that time and hope you just miss any of the mistakes I made. Some of the same functions to get a person from a table, strip the zip code extensions, add the combined address. Now we have some functions that start to do a little bit more. We have lives in state. Takes a person and a state, and it tests whether the state for that person equals the state. A simple, an atomic unit of functionality which just tells true or false, does this person live in this state? For now, I'm going to leave it this simple, though if you're doing this in a JavaScript production environment, you'd probably want to add some checks to make sure person is actually an object. The Lodash get function that has to handle some of that type checking and null checks for you, and tends to default it to if it's not an object or it doesn't have this property, you'll get undefined, so this will always be false, and for now that's good enough. And from there we have the same code as otherwise. The people IDs, we get the person from the table, and then we have selected people IDs. Say the front end has already gotten all of the information from the database, but now we only want to check certain of these to get a new selection set. So we're going to take a const selected people, filter over the working data, and if the person has the ID, that's going to be the set we're going to get. We're going to reduce from the full set to only the set matched by these IDs. We're taking an array, applying it to another array, getting an array out of it, and it's still effectively, even though I'm breaking this up for readability purposes, two lines of code. One line for the extra data, one line for the operations we're using it for. Then to prove it works, we have selected people in the log, and then for people from Alabama, I'm going to filter on the working data and return whether or not people lives in state person in Alabama. I think I've forgotten to explain how this works in Lodash before, but the way the filter works is if this lambda function returns true, it's included and it survives the filter. If it returns false, it won't. And so going back to this takes a person and returns whether that person lives in state. And then we do the same thing to map to the log statement and output it. And if any of you figured that out on your own just by reading how the code looks, we'll say, hooray again for functional programming, to write things in a bit simpler so it's intuitive and easier to reason about is the propaganda/party line. But if you don't get too abstract, this really does help. And then the log statements to prove that this actually works. Got the wrong thing again. So selected people, they were 1 and 2. ID 1, ID 2, end of data set. Then one lives in Alabama, one lives in Kentucky. People from Alabama, we've got 1, that's Alabama, done. And that is literally it. Any questions at this point? Fair enough. Live demo number 3. And in case you're getting bored, there are only 4. I didn't screw up on that either. And then we're done with the presentation. So, live demo number 3, same data set, same functions, something pretending to be a database. And then, but we had some different transformers out there. We were like stripping zip code extensions, adding combined addresses, and well, they all function the same. Why should we have a different way of treating them? Another layer of abstraction out for it. So we're putting them into an object where the name of the transformer is the object keys. Due to the way some of the tricks you can use with JavaScript, this lends a way to getting a bit more human readable code as far as validating, whitelisting, and figuring out how you do what to certain data. And so we've put in the strip zip code extensions and the add combined address functions you've seen earlier, wrapping them in a new home. And then we're also with the filters, we still only have 1, but we could potentially have more than 1. So we're putting all of these into a filters object and indexing by the name that they used to have. And then getting a bit more fancy, we're isolating our side effects into something that explicitly marks itself as a side effect, in this case IO, just for a future reference. And this is the one that demonstrates a bit of the reduce functionality. So we have some irrelevant to those code here to show you the equivalence between join and a longer way of writing it for reduce. The proof, which we will see down here in the console when I fail to expand it properly again, because third time's the charm. And then back to working with the data. We've got the people IDs, where we're going to get person from the table. And on the working data, io.log. Then we're going to pull the transformations to apply from our transformations object to keep it a bit simpler. And this is, we are putting that into an array. And we're talking about the transformation sets with the reduce. We're at that point now. Because we are starting with an array of transformations to apply. But that's not necessarily, we don't have to start with the accumulator and a reduce function to be one of the transformations. We can feed anything to it. And so we're actually starting with the working data. And so for each, so to read this in a less tangled up way is we're going to take all of the transformations to apply, starting with the working data, which becomes the accumulator. We're going to apply each transformer function to this with the map, and then return the new array. So this is effectively a one-line code way of saying, take working data and apply everything in this array in it in succession. It's one of the tricks you can do when functions are first-class citizens in a language, because they're able to be passed around like primitive data types, and allows you to streamline code in this fashion. It takes a while to get used to it. If you haven't seen it at first, you may want to breakpoint it to figure out what's going on and what the steps are at each point. But once you start to get fluent in this type of syntax, you can start writing and reading code like this a bit faster and understand what's happening. I use this a lot at ZealCon. Technology Partners, which used to be ZealCon and everything else, are still dealing with the change and mentally flipping over. And in my day-to-day work, it's surprising how often a lot of the working with databases and the data sets will simplify down to a sequence of nested or sequential maps, filters, and reduces. Makes things a bit easier to write and to figure out. And when combined with some of the more advanced Lodash functionality like implicit and explicit chaining, makes debugging a little bit easier.
I'm still having trouble seeing how that's a reduce, because it's like, can you leave?
Sorry. Yes, Kevin?
Yeah. It's a reduce, but it's a sequence of it's a series of map operations that you're calling a reduce.
Yes, it's
and where you have the same number of inputs, the same number of output each time. But reduce typically reduces to one value, so that's why I'm having trouble.
all right. For the people online, Kevin was asking about trouble seeing how this is a reduce, because a reduce goes from many values to one value, but there are maps inside which keep the same structure and size of the arrays that are going into it. And this is one of the parts where functional programming can get kind of mental intensive, is when you start, as in this case, nesting maps, filters, and reduces inside each other. Basically, the way this one is working is in a descriptive way to work is that we have an array of transformations to apply, and we want to somehow turn that array into a single value, which is our data set after all the transformations have been applied to it. That's the reduce part.
You're reducing it to one transformation.
No, not quite. Not reducing it to one transformation. Maybe if I could get a running start at it, I could throw enough words at it that you'll find something to hold on to.
One
And
way to think about it is the functions are objects, are values, and you're reducing a collection of functions and your writing data, or your working data, down to one final structure, which is considered one value.
The final structure being the array that's
yes.
the same length as the one where.
Yes, I'm not sure how much you caught on that online, since I've got the microphone and they don't. But it was different ways of explaining it.
All right.
And because our final data structure is an array, inside of it, inside of the reduce, we want to make sure we're applying the transformation function to all the elements of our final array, which is why we have a map nested inside a reduce. I see skepticism on that
I
face,
gotcha.
and that's
I
fine.
think
That's why I have the
I'm in the-
logs
yeah.
to prove this.
Good enough.
Okay.
It may help you, Kevin, to know that this JavaScript reduce is equivalent to the Scala fold
Oh,
as opposed to Scala's reduce. I don't know if that
That-
helps
that
with
does
the
help.
impedance mismatch
that
there.
does help.
Okay, and Darren was just pointing out that the JavaScript reduce is equivalent to a Scala fold. And so if that helps here, it might help someone online. Thank you. And then as far as mentioning in the description earlier in the presentation, is you can also use reduce to set up a functional, like a piping functionality, where you're going to take data and apply a set of functions to it, which is what we're effectively already doing. You can set it up with the structure like this, where our pipe or our list of functions we are going to perform on a specific set of data is we're going to get the person from the table, strip the zip code extensions, add the combined address, and then log it out. And this links into some of the functional programming ways of saying that you're going to define a sequence of operations but not actually execute them yet for lazy evaluation. This is one of the ways to implement that in JavaScript. You're going to define your pipe, and then you're going to use reduce to implement it at runtime. That way you can see what it looks like beforehand, and then trust that when you cram everything in there, it's going to run as you expect. And here are the console logs here, where we're going to start with all the people IDs, run the function, map over the functions for each of one in our people IDs, and do the stuff. The definition, don't do that. The definition, implementation. And because we are working at the level of abstraction of functions, this is extractable and reusable, since these are the only unique parts of it, and it is conceivable that you could put this, you could compose this inside another function where you get those in from somewhere else. Then you'd have a reusable abstracted piece of code, which is the functional programming ideal. Everything's supposed to be like that. And as far as a brief run through for the proof, here we start at the top with the join and the reduce for that part to show that those two structures are equivalent as far as the inputs and outputs go, so they can be substituted for each other. And the slow scroll through the working data, and I've been talking a bit since then, so I no longer have the beginning still in my working memory. But this is online. You can see it for yourself. You can mess around with it for yourself and break it if necessary. And so, the transform data, right to the next step, and then the pipe, where we start out each and implement each in turn. Any questions from the room on this section? There do not appear to be any. Excellent. Now, the last live demo, which incorporates the intersection, union, and difference methods as ways to take this toy example into something closer to including some of the checks you might want to have in a production environment. As usual, we've got the data. I've got two sets here to work with. Transformers, where we have the names here of what they want to be. Here, and so we've got names 1, names 2. So we are taking, we've got data 1 and data 2, like two different databases. Yes? 5 minutes. Oh, 5 minutes. Okay. This was timed pretty good. I'm almost done. We've got the names here, like we've got the names from 1 and the names from 2, like you just want to pull some usernames for a card display from different data sets. Then we have a names union, and we've got a data union. And the second one this is mainly there to show you that Lodash has a bit more functionality than just the basic union, and we're using union by, because this third is a function that we run on the data before Lodash checks to see if it's equal. It's a bit more complicated. If you're interested, I've got 5 minutes or less. I would refer you to the docs at this point. This is also how you can make sure that you're not duplicating data from different sources. Got some console.logs to, again, show the proof. And then here we have a combination of validating the arrays against arrays and making sure that you're running commands you're able to do in this transformers engine section, where the keys to the transformers is to get the object keys from the transformers objects. And these, coincidentally, are the only transformations that are available to run because we haven't defined anything else on program time. So we are going to get their names. Then they're going to be transformers to apply, which is the intersection of the available transformers and the transformer set, which is being passed into the engine. That way, instead of having to pass function names in, you can pass the string literals in to make it easier for someone coming back to read what you're trying to do to the code once it starts. Because once it starts to get this abstract, it gets a bit easier to get lost into it. And we're not even close to monads, higher kind of types, structures like that. And so if you were just starting out, maybe you don't want to jump into that much of the deep end. And so using the intersection, the available transformers are going to be the intersection of the ones you're trying to try and what's actually available, and so you're never going to be able to run anything that doesn't already exist. Here's the logic. If they are not equal, that if the transformer set is not the same as the transformers to apply, you know they have something wrong through logical deduction, so we can get the difference and then log those out to show you what those are. And then we do the same reduce pipe function that we used to do in the previous example to actually run the transformers. And so then on the code, once this is abstracted into its own module, this is what the code looks like to simplify the reading and scanning. Any questions? None in the room. Well, thank you. Thank you for bearing with me on this and going through the code and the descriptions and me losing my place a couple times. If you are interested in delving more into the deep end of a functional programming paradigm as it is implemented in JavaScript, Dr. Boolean's Mostly Adequate Guide, available on Gitbooks at this address, is a great start. It does jump straight into some of the ideas of monads and category theory, but it also includes example code that you can write yourself and a pretty weird sense of humor, so I believe it is appreciated. And with that, thank you for your time. Thank you to Techlahoma and Lambda Lunch for hosting me. And I hope you found it worth your while. Take care.